In this session, let us discuss about the armature reaction. Of course, we discussed about armature reaction in our previous session, but still, in motor, what will happen? And let us conclude, generator and motor to a single point. Okay. For example, in this section, let us assume that this is a motor. Okay, DC motor. Okay, motor in the sense my brushes should be here. Okay, and in motor, what is the input in motor? Okay, in motor, my input is current. Okay, so once you give current, electrical input, automatically it will be converted into mechanical, that is rotation. Okay, so for example, these are the conductors, and maybe upper section let me give dot currents, and lower section let me give cross currents. Okay, if I give this way, what will happen? These are going to be currents. Okay, so whenever current is there, automatically flux will come. Now that flux will be cross here, dot here. See, cross here, dot here. So my MMF is directed in this direction. Okay, so MMF is directed in this direction. For example, you are sitting in the air gap. Okay, so you are sitting in the air gap and flux is coming out of this particular rotor. So this pole should be N pole. Okay, so this is going to be N pole of the rotor, S pole of the rotor. Okay, if you get any doubt how to find the direction of induced voltage and how to find the direction of torque developed, go back to basic concepts of rotating machine. Now N pole, S pole, attraction will be there. N pole, repulsion will be there. S pole, N pole, attraction will be there. So torque will be developed in this direction, electromagnetic torque. Okay, so the moment torque is developed, automatically rotation also will start in the same direction. Okay, now already we know that, and in basic concepts of rotating machine, we analyzed that at any cost, induced voltage direction should be against to the polarity of your direction of current, against to the direction of current, so that will fall automatically in place. Okay, so what is our intention now? In order to find the direction of MNA shift. Okay, so under no load conditions, for example, if currents are not there, under that condition, my MMF or flux by the poles will be in this direction. Now because of this presence, what will happen? Let us see. Now let me draw the rotor again. Okay, so if I try to draw the rotor, okay, so here brushes, and here upper portion dots are there, and in the lower portion crosses are there. Okay, so lower portion crosses, upper portion dots. So what's happening? My currents are in this direction, so flux is in this direction, so it is becoming like an N pole, it is becoming like an S pole of the rotor. Okay, so my flux start traveling in this direction. Okay, in this case my flux is going to, cross dot, flux is going to travel in this direction, so flux is going to travel in this direction. Okay, now if you think of field flux, how my field flux is there? Field flux is N to S, so field flux is in this direction. Field flux is in this direction. So where it is getting aided, where it is getting opposition, if you see, for example, here this is in downward direction, this is in upward direction, so here opposition will be there. Okay, and here if you see, this is in the same direction and armature flux is also in the same direction, so this flux will try to travel here. Okay, now if you see the other end, what is happening? Here and here aiding are there, here and here opposition are there, so because of this, my net resultant flux is going to be directed in this direction. Okay, so this flux line also, because of this opposition, will travel like this, net flux will go like this, and here opposition is there, so net flux has to travel like this. Then what is the new MNA? For example, if you think of only field like this, MNA is exactly 90 degrees to it, MNA will be here. But now because of this, my MNA got shifted in this direction. MNA. Okay, so magnetic neutral axis is 90 degrees to the resultant flux. Because if I keep conductors here at MNA, how much will be the induced voltage? Will become 0. Okay, so MNA is shifted in this direction. Previously MNA was here, now MNA is shifted in this direction, means that for example my MNA is shifted in this direction, this is going to be new MNA. Okay, so what has happened? MNA shift is against to the direction of rotation. Okay, previously when armature current is not there, my MNA was here. Now my MNA shifted in this direction. What does it mean? It is meaning that my MNA shift happened. The MNA shift happened against to the direction of rotation in motor. MNA shift, in our previous session we discussed, we concluded that MNA shift will happen in the direction of rotation of rotor in case of generator. So conclusion is very simple. In the generator, MNA shift will be in the direction of rotation of generator, and MNA shift in motor will be against to the direction of rotation of motor. So that is the conclusion. If you remember this, remaining all will automatically fall in place. Now, as we discussed, if I think of MNA, now if I keep brushes at MNA, in our previous sessions we have seen, if I can keep brushes at MNA, voltage tapped across the brushes will be maximum. Okay, so and again one more thing is commutation. Okay, some sparking will happen. Why sparking and all? Detailed analysis, anyway problems cannot come from there. Because of that, sparking will come. I know, forget about it. Now coming to point here. Okay, let us think of this. Okay, ring winding. In ring winding, for example, if brushes are placed here, okay, under no load condition, what will happen? For example, in this particular conductor, 10 volts is the induced voltage, and in this particular coil, for example, 9 volts is the induced voltage. For example, in this coil, 9 volts is the induced voltage under no load condition. Now across the brushes, from brush, if you travel, see here, from the brush, if you travel, this is the coil, this is the coil, this is the coil, this is brush. So across the brush there are one parallel path, another parallel path. So these two parallel paths will be there, and now this is going to be, how much will be the voltage across the brushes? If I keep brushes here, is going to be 9 plus 9 18 plus 10 28 volts. It's fine. Okay, in the upper section 28, in lower section 28. Now if you think of current, for example, current is flowing in this direction. This is connected in series with this same, this is connected in series with this same, and this are connected in series, such that IA by A, in the sense this is going to be conductor current. This conductor current will come and come out like this. This conductor current will come out of like this. So both two conductor currents is going to be net current. Okay, so if I think of output current as IA, armature current IA. Okay, so how much current will be given by this? IA by 2. Current given by this will be IA by 2. Getting my point, right? So point here is IA by 2 total is going to be IA, because two parallel paths are there. If I have A number of parallel paths, IA by A will come. Okay, forget about it. Now coming to the point, for example, if you shift the brush. Okay, so for example, in the direction of rotation of generator or against to the direction of rotation of motor, what will happen? For example, if brush is shifted to here, okay, then what will happen in this? If you observe, now this are connected in series. So because brushes are here, so brushes are placed here, then what will happen? This current direction will be reversed. This current direction is as usual. This will be IA by 2. Okay. Now this current direction will be as usual. This current direction is reversed, and this current is IA by 2. Okay, so conclusion is very simple. What is that? Because of, for example, of course, normally we don't do that. Brush shifting and all we don't do in any practical generator or motor of DC machine. Okay, but still, for example, if you are thinking of, in order to meet MNA, if you think of changing the brush axis, what will happen is our intention. Okay, so for example, if you change the brush axis, depending upon the brush axis only, currents will be there in conductors. Okay, so induced voltage, magnitude of induced voltage will be decided by the flux density they are influencing, but direction of current will be decided by the brush. Okay, now coming to the point. Okay, anyway, we concluded here that depending upon the brush axis, direction of currents will be there. Now let us take one more. Okay, so in this section, let us see, for example, generator or motor is anything for us, because in generator my direction of rotation should be in the direction of rotation of rotor, M&J shift will be there. In motor, against to the direction of rotor, M&J shift will be there. For example, let us think of motor or generator, your wish. For example, in generator, we have to rotate the rotor. Okay, for example, let us think of generator, and I am rotating the generator in this direction. I am rotating the rotor, okay, because always, like, in generator we have to rotate the generator. Input is going to be mechanical input. For example, I am rotating in this direction, and we have to find induced voltage. How to find induced voltage? Right hand. Okay, so for example, flux is going like this, and in order to find induced voltage and all, if you get any problem, just go back and revise basic concepts of rotating machines and come back. So N pole is like this, and the rotor conductors are rotating like this, so induced voltages will be cross here, cross here, cross here, cross here, cross here, dot, 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 dot. Okay, now for example, if I keep brushes here only, okay, so if I keep brushes here, then what will happen? Current direction in a generator will be aligned with the direction of induced voltage, basic concepts of rotating machine. So currents are going to be dot here, dot here, dot here, dot here, dot here, cross, 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 cross. Okay, so such that currents will flow. Now, for example, in the direction of rotation of generator, M&J shift will be there. For example, I shifted my brush axis. To here. Okay, so in the direction of rotation of generator, I shifted my brush axis. Okay, so if I shift my brush axis, then what will happen? My new currents are going to be, current here will be dot, current here will be dot, 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 and current here will be cross, 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 and this will become cross. Okay, for example, if I shift my brush axis by theta degrees, okay, then what will happen? Okay, basically my armature reaction of DC machine is going to be only cross magnetizing. Okay, so for example, if you come back and see here, okay, so if you come back and see here, my armature flux is trying to cross magnetize. So always in my DC machine, cross magnetizing armature reaction effects only will be there. Demagnetization or magnetization armature reaction effects will be there only in synchronous machine. Okay, so now point here is, normally it will be cross magnetizing only, but because if you see, like, everywhere it is going to be cross magnetizing. Okay, everywhere it is going to be cross magnetizing, so directly demagnetization will not be there in DC machine. Okay, for example, if you use brush shaft, then, like, demagnetization can happen. Let us see how. Okay, so for example, let us think of like, it is shifted by theta, no? So let me take in this direction also theta. Just wait there, like, you will come to know. Let me take in this direction also theta, and this is anyway brush shift axis theta. Now try to apply simple right hand thumb rule. Okay, for example, how many ampere turns are there for cross magnetization? How many ampere turns are there for demagnetization? For example, see here, now we have to think of blue. Okay, so if you think of blue, cross magnetizing, only these three conductors only, cross here, dot here, cross magnetization or not, because my field flux is going in this direction, and except this 2 theta. Okay, except this 2 theta, this 2 theta, what is happening? This is going to be cross dot, which is going to be cross magnetizing. Okay, now if you think of these 2 theta areas of blue line, what is happening here? This is going to be cross here, this is going to be dot here. Okay, so this is going to be cross here, this is going to be dot here, it is in this direction. So my field flux is flowing in this direction, and some ampere turns are coming in this direction, so that is going to be demagnetizing ampere turns. Okay, so this is going to be cross here, dot here, demagnetization, and cross here, dot here, cross magnetization, because field flux is in this direction. Okay, so what is happening here? Per pole. For example, if I shift axis by theta, okay, so it is going to be 2 theta, it is going to be 2 theta, so 4 theta areas are there. Okay, in that 2 poles are there. Now how many demagnetization ampere turns per pole is going to be 2 theta, because 4 theta for 4 poles, sorry 2 poles, 2 theta is for 2 poles. Okay, now let us write an equation. Even in recent comment also I have seen, do we need to remember, like, you know, demagnetization, cross magnetization, interpole winding is not required. Just follow with me. For example, what is armature MMF normally? Like, you know, just a minute. Yeah, so armature MMF, which is cross magnetizing without having any brush shape. Without having any brush shape will be how much? Armature MMF per pole. Okay, so what is armature currents? IA by A. Currents, ampere turns. So how many turns are there? Z by 2. Z is the number of conductors. Ampere turns per pole. Okay, so total armature ampere turns per pole is going to be IA by A. Very simple, ampere turns per pole. Now how much current is flowing inside the armature? IA by A. Okay, in our previous section we have seen 2 parallel paths. Out of 2 parallel paths, 1 parallel path conductor current. Out of 2 parallel paths combinedly is going to be IA after the brush. So before the brush, IA by A, current ampere, Z by 2. Z is the total number of conductors by 2 number of turns per pole. Is there anything to remember here? No, not required. Anyway, now out of this, if I have brush shift of theta, okay, so how much will be the demagnetizing ampere turns per pole? Demagnetizing is going to be 2 theta by 180, okay, into FAR, armature MMF. Okay, so total armature MMF per pole, out of that 2 theta, for example, 2 theta will be given to this, 2 theta will be given to this. Okay, so 2 theta by 180, because out of total 180 degrees of electrical actually, so out of total 180 degrees, like, you know, 2 theta should be given to demagnetizing. Remaining, like, you know, remaining is going to be cross magnetizing. Okay, so this is going to be the thing for without having any brush shift. This is the thing for only with after having brush shift. Okay, so means if I detect this from here, if I detect this is going to be remaining cross magnetizing ampere turns per pole. Okay, now for example, if I shift the brush axis, actually we concluded here that if I shift the brush axis in the direction of rotation of generator or against to the direction of rotation of motor, means it is going to be demagnetizing ampere turns per pole. Getting my point, right? For example, you try to move the brush axis against to the direction of rotation of generator or in the direction of rotation of motor. What will happen? Let us see. Okay, so in this example, let me consider motor, because generator I considered. Let me think of motor. That's it. We need not be scared. Like, everything fall in place. For example, if I think of motor. Okay, so in motor, what has to be the input? Input should be current. So for example, my wish, dot, cross are going to be currents. Okay, so currents in the sense, as usual, cross dot. Whenever you have current, automatically flux should come. Cross dot. So this is going to be N pole and this is going to be S pole. NS attraction, so it start rotating in this direction, omega. Okay, because NS attraction will be there, SN attraction will be there, it start rotating in that direction. For example, you shifted the brush axis in the direction of rotation of motor or against to the direction of rotation of generator. For example, you shifted the brush axis in the direction of rotation of motor, means that you shifted to here. Then what will happen? Now current is going to be, because means immediately brush will decide the direction of current. Okay, so now currents will be changed. So this is going to be dot current, 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 this is going to be cross current, this is going to be cross current, cross, and this is going to be dot current, because brushes are here now. Okay, means that if you change the brush axis in the direction of rotation of motor or against to the direction of rotation of generator, what will happen is the point of interest here. Okay, now as usual it is rotated by theta degrees, for example. Theta means that opposition side also, let me remove theta. There is one more theta. Okay, so this is going to be 2 theta as usual. 2 theta. Now apart from these 2 theta, what is happening? Like cross dot. Only these three conductors cross dot. Okay, cross dot. Cross magnetizing or demagnetizing or magnetizing? Cross magnetizing, right? So pole flux is like this. Okay, pole flux is in this direction and my another flux is going exactly 90 degrees away, cross magnetizing. Okay, now let us think of remaining 2 theta portion per pole. Are they going to give magnetizing or demagnetizing? For example, my field is going like this, and my armature conductor currents of this 2 theta and this 2 theta cross dot. You got my point, right? So cross dot means that what is happening? My field flux is in this direction. Okay, my field flux is in this direction and my armature flux is also in this direction only, so it is going to be magnetizing. Okay, formula will be same, formula remain the same, formula is going to be the same. Okay, but it is going to be magnetizing. Now in this case, magnetizing armature reaction is going to be 2 theta by 180 into FAR. FAR is going to be same. So conclusion is very simple. Before closing the session, let us conclude. What is that? Normally, if you don't have any brush shift, if you keep at your GNA, geometrical neutral axis, okay, then under no load conditions, MNA will be aligned with GNA, but under loaded conditions, my MNA will be rotated in the direction of rotation of generator or against to the direction of rotation of motor. Now, for example, in order to catch MNA, if you try to shift your brush, in practice we never do that. Okay, so if you try to shift your brush axis, in the direction of rotation of generator or against to the direction of rotation of motor, what will happen? Some ampere turns will be demagnetizing, remaining will be cross magnetizing. For example, against to that, if you try to move your brush in the direction of rotation of motor or against to the direction of rotation of generator, some part of the armature reaction effects will be magnetizing. Remaining portion will be cross magnetizing. Okay, formulas we need not remember anything. Ampere turns per pole, ampere conductor current IA by A, turns total number of conductors Z by 2 number of turns, per pole 1 by P, over. Okay, so in each per pole it is going to 2 theta area by 180. So 2 theta area is going to give you cross magnetizing or demagnetizing, deal done.